Hello everyone. In this video, I'm going to show you how to determine the tensile strength VPM for double angle tension member. In this example, the double angle tension member was bolted to a gusset plate back to back. The dimension of the double angle is 8x4 by half, which means one leg is longer than the other. It is made of A36 steel. The diameter of the bolt is 7 by 8 inches, and the lateral spacing between the bolt is 1.5 inches, and the vertical spacing between the two rows is 3 inches. So we're gonna determine VPN considering all the tension member limit states, including yielding, fracture, and block shear. First of all, we're going to do all the calculations for just one angle and multiply result by 2 at the end of the problem. First, we're going to check yielding on cross section. So the cross section for one angle is 5.75 square inches. So the VPN based on yielding is 0.9 times Fy times Ag equals 186 kips. And then we check the fracture in net section. So there are two potential failure paths on the double angle member. Number one is the failure path along A, B, and C, which is the straight path. So AN for path ABC equals the total, the gross cross-sectional area, 5.75 square inches, minus the area of the hole. So along the path ABC, there is one hole. So the diameter of the hole is 7/8 inches plus 1/8 inches times the thickness, half inches, equals 5.25 square inches. And the other possible failure path is A, B, D, E. A, B, D, E. So there are two holes along the path ABDE. So the area going to be deducted from the total cross-section area. And there is one zigzag path along ABDE, so it will also be accounted for. So the net area for the path ABDE would be equal to 5.75 square inches minus the number of the holes, 2 times the area of the holes, 7/8 inches plus 1/8 inches times the thickness, half inch. Okay. And then plus zigzag, right? So that's going to be 1.5 square divided by 4 times 3 inches, and times the thickness, equals 4.84 square inches. So the smaller one would control, right, would be the controlling net area. So 4.84 square inches is going to be used to determine VPM based on fracture. So since there's only one leg is bolted to the gusset plate and the other leg is free, so shear leg coefficient U should be smaller than 1. And we can determine U by using this equation, right? X is the distance from the centroid to the interface between gusset plate and the double angle. So from the menu, page, see, page 1-44, you will find out the centroid to the interface is 0.854 inches. From AISC page 1-44. Okay. And L is the length of the connection. So the total length gonna be let's go back. See. So the total length of the connection gonna be 4 times 1.5 inches. So L is 4 times 1.5 inches equals 6 inches. So plug X and L into the U equation, we get U equals 1 minus 0.854 divided by 6 equals 0.86. So AE is equal to U times the controlling AN, which is equal to 0.86 times the controlling AN, 4.84 square inches. Eraser. 4.84 square inches. Okay. From there, we can find out the VPN. Oh, so it's already here. VPN based on the fracture failure mode is 0.75 times FU times AE. So it's equal to 0.75 times FU. FU for A36 is 58 KSI. And times the effective area. From there we get 4.16 square inches. Okay, so times 4.16 square inches equals 181 kips. So, all right. And then the third limit state. The third limit state for block shear is block shear. So we have to consider all the possible failure blocks. So these are the 3 possible blocks, tail out blocks, 1, 2, and 3. So we have to check all the 3 conditions. Okay. So first of all, we want to check the VPN based on block shear number 1. Okay, so so the shear, there's going to be tension fracture along this cross section, and the going to be sheared off by the horizontal section, right? So nevertheless, we have to calculate the 4 different areas: gross shear area and net shear area. So V means shear, right? And the gross tension area and the gross net shear, gross net tension area. So let's see how to calculate the gross shear area. So the uh, the member gonna be sheared off along the horizontal path, right? So the gross shear area gonna be the 7.5 inches times the thickness of the plate, which is 0.5 inches, equals 7.75 square inches, right? And the net shear section, just use the gross shear area subtracted by the whole area, right? So along the shear path, there are 1, 2.5. So they're gonna be 2.5 holes along the shear path. So so A and B gonna be equal to the gross shear area, which is 3.75 square inches, subtracted by the whole area, the total whole area, which is we have 2.5 holes along the path, and times the whole diameter, 7/8 inches plus 1/8 inch, and times the thickness, 1/2 inch, right? Equals 2.5 square inches. Okay. And then the tension. So the tension area gonna be along this path, right? The red path. So the gross tension area gonna be 5 inches times the thickness, 1/2 inch, equals 2.5 square inches. So the net area is the gross actual area subtracted by the whole area. So along the tension path, so there's half holes should be deducted, right, from the gross cross-sectional area. So A and T gonna be equal to 2.5 square inches minus half of the whole. So that's 0.5 times the whole diameter times the thickness, equals 2.25 square inches. All right. So recall the block shear is the lesser of 0.75 of this item, and 0.75 times NT FU plus a MV times 0.6 FU, right? So you want to compare. That's why you want to compare these two items. So A and B times 0.6 times FU equals 2.5 square inches times 0.6 times FU, which is 58 KSI, equals 87 K. And AGV times 0.6 times FY equals, so AGV we calculated as 3.75 square inches, right? And times 0.6 times 36 KSI. So that equals 81 kips. So we know that the this item, so AGV times 0.6 FY would control. So this one would be controlling. So VPN for so we're going to use this equation to calculate VPN for block shear number one block shear, right? So which is equal to 0.75 times ANT times FU would be equal to 2.25 square inches times FU, which is 58 KSI, and plus the second item we already calculated as 81 kips. And then we get the VPN is 159 kips. Okay, so that's the VPN based on the block shear failure like this. Okay. Similarly, we have to check the VPN based on this shape of block shear, right? So we just repeat the same procedure. So determine the 4 areas in order to calculate the block shear, right? So AGV, which is the same, right? Which is the same as we calculated before. So AGV is still based on the shear path, right? Based on this one. So AGV stays the same, so that's still 7.5 inches times 0.5 inches equals 3.75 square inches. Okay, and AMV, net cross-sectional area, so this also stays the same as the number 1 shear block. So that one still equals to the gross shear area subjected by 2.5 holes, and the diameter of the hole is 1 inches. The thickness is the ½ inches. So it's the same result, 2.5 square inches. And now the tension area changed. Right, so now the tension path include the zigzag path. Right. So AGT equals AGT still equals 5 inches times the thickness, ½ inches, 2.5 inches. And the net area, that's the include 1 zigzag path. So is equals to 2.5 square inches minus, so that's 1.5 hole is going to be deducted from the gross tension area. So that's 1.5 holes times the diameter of the hole and times the thickness equals, oh sorry, and we have to account for the inclined path. So plus s squared. S is the lateral spacing, right? So it's 1.5 squared divided by 4 times g. G is the spacing between the two rows. So 4 times 3 and times the thickness, right? And gives you a number of 1.84 squared. And at the same, we want to compare these two items to see which equation would be controlling for VPN, right? So ANV times 0.6 times FU equals 2.5 square inches times 0.6 times 58 equals let's write it here, equals 52 kips. Okay, and then AGV times 0.6 times FY equals 3.75 square inches times 0.6. Fy is 36 KSI equals AGV. there's an error here. So this one should be still equal to 87, right? So that's what we did before, and this one keeps the same. Still 81 keeps the same as shear block 1. So so VPN would be controlled by AGV. So eventually VPN equals 0.75 times ANT. So ANT changes. So ANT now equals 1.84 square inches, and times FU 50A KSI, and plus 81 equals 141 kips, and we noted that this number is smaller than shear block 1. Okay, and the next, the number 3 possible block shear. So there is one bolt was left out in this shear block. So there's a difference. That means the block only carries 4/5 of P. Okay, so now so AGV gonna be different, right? So the length, the shear length gonna be 4.5 inches. So this path is 4.5 inches long. All right. So the gross shear area equals 4.5 inches and times the thickness 0.5 inches equals 2.25 square inches, and net shear area is 2.25 square inches minus, so there are 1.5 holes along the path, so subtracted by 1.5, and 1 inch and ½ inch in thickness. So that's going to be equals 1.5 square inches. And the tension pass. So now there is one inclined path along the tension. So let's use the green line. So that's the tension path. Right? So the tension pass still equals 5 inch times 0.5. 0.5 inches, 2.5 square inches. So note that the tension area is still equals to 5, the straight line 5 times the thickness. So don't have to account it for the inclined line. So the tension cross-sectional area stays the same regardless regardless of the inclined path. Because the addition of s squared divided by 4g is only should be added to the net area. So the net tension area equals 2.5 square inches minus, so there are 1.5 holes, 1.5 holes along the path. So minus 1.5 times the hole diameter 1 inches times the thickness 0.5 inches. Okay, and then don't forget to add s squared divided by 4g. Right, so that's 1.5 squared divided by 4 times the spacing 3 inches and times ½ inch thickness. So ANT equals 1.84 square inches. Okay, and this is the same. Compare these two items to see which one controls. So it should be the same as we did before, right? Because AMV and AGV doesn't changes. So there is AMV and AGV. Okay, so AMV So AMV equals 1.5 square inches times 0.6 times 58 KSI equals 82 kips. And AGV is 2.25. 2.25 square inches times 0.6 times 36 KSI equals 49 kips. Okay, and as we said, that this blocks only carries 4/5 times P load. So VPN would be equal to 5/4 times 0.75 times the block shear, right? So it's equal to 5/4 times 0.75 times ANT. FU is 1.84 square inches times 58 KSI and plus AGV, so the smaller one control, which is 49 kips equals 159 kips. Okay, so this number actually accounts for the reduced load carried by the load. Okay, so if we compare VPN based on block shear 2 is 141 and block shear 1 is 159 and then based on fracture is 181 and the yielding is even greater, 186. So we can see the smallest VPN would be 141 based on the number 2 block shear failure. Okay, so the eventually the VPN for the double angle tension number equals 141 kips.